Hello students, how are you all? I hope you all are fine and in high spirits. Today we are going to study Euclid's Introduction to Geometry. Let's start. Euclid. Euclid's full name was Euclides. He got his primary education from great philosopher Plato's academy at Athens. Around 300 BC, Euclid, a teacher of mathematics at Alexandria in Egypt, he collected all known work of mathematics and arranged it in a treatise called Elements. Elements was initially called Stoichia, but when it was translated in Europe, it was given the name Elements. Euclid divided Elements into 13 chapters. Each chapter was called a book. These books consisted of world's whole knowledge of mathematics and particularly understanding geometry. Euclid has given 23 definitions in his first book. Let's see some of these definitions. First of these definitions is point. A point is represented by a single dot on a surface. It has no length, no breadth, no area. A point is represented by this. This dot is called a point in geometry. Next is line. Let's see how Euclid defined line. A line is breadthless length. Now what do we mean by a breadthless length? That is this. This is a line. It has no breadth, it has only length, and as you can see, there are two arrows at the end. It means that this line can be extended in both directions, as you can see on the screen. Now this way the line can be extended as much as required. This is one property of line. And how is a line made? A line is made by the combination of infinite points. Now this is how a line is made. That means this line has infinite number of points which are joined, and the line is extended in both the directions. So students, always remember, a line can be extended in both directions, so it cannot have any fixed length. So this is how Euclid defined line. Next is surface. A surface is that which has length and breadth only, like the top surface of your book or the surface of a blackboard and any wall that you see on your front. Now all these are surfaces. I hope you can recall what a surface is. You can even see the top of your table. It's again a surface. Next is the edges of a surface are straight lines. As you can see on this whiteboard, this straight line, this is the edge of the board. This again the edge of the board. You can see this is again a straight line. You can see the edges of the surface of your book or your mobile or any wall or even the tabletop. All these surfaces, their edges are always straight lines. Next definition is plane surface. A plane surface is a surface which lies evenly with the straight lines on itself. As you can see on the plane surface of your book or a blackboard, a door or window. It lies evenly with the straight lines. This is called a plane surface. Students, starting with the definitions, Euclid assumes certain properties which were not defined. For example, point. There was no definition of point. It was just represented as a single dot to represent the position of an object. Now, these assumptions were called universal truths, and Euclid divided these assumptions into axioms and postulates. Axioms were the assumptions which were specific to geometry only. Now, axioms were those assumptions which were specific to geometry, whereas postulates were all other assumptions throughout mathematics which were supposed to be true. Other notions covering throughout mathematics. Now, we will study these a bit further. Let's go. Now, let's study about Euclid's axioms. First axiom is things which are equal to the same thing are equal to one another. For example, if A equals C and B equals C, it means A and B are both equal to C, then A will be equal to B also. So, this is what we call things which are equal to the same thing are equal to one another. This was Euclid's first axiom. Let's see the second. If equals are added to equals, the wholes are equal. Like if A equals B and C equals D, then A plus C will be equal to B plus D. Let's study Euclid's third axiom. Third is if equals are subtracted from equals, the remainders are equal. Like if A equals B, then A minus C will be equal to B minus C. So, we have subtracted the same C from two equals A and B, and that's why their difference will be equal. That is, A minus C will be equal to B minus C. Next axiom is things which coincide with one another are equal to one another. Students, coincide means that the two overlap each other completely. It's obvious that if two things coincide with each other, it means they will be equal and same in shape as well as size. We can see some examples. First is we have two circles. They both coincide with each other. That means when we bring them closer, we can see that they both are overlapping each other completely. It means their radii are equal to one another. Similarly, we can see two line segments. They also coincide each other. That means their lengths are equal. So, thus we prove Euclid's axiom number 4, that is things which coincide with one another are equal to one another. Now let's see the fifth axiom, which says the whole is greater than the part. As you can see in the picture, A is a whole and B and C are its parts. So we can clearly see A is greater than B and also A is greater than C. Students, now let's see Euclid's sixth axiom. Things which are double of the same things are equal to one another. Like if A equals 2C and B equals 2C, then A equals B. See, A and B both are equal to twice of C. So, A will be equal to B. Now, let's see Euclid's seventh axiom, which says things which are halves of the same things are equal to one another. See, if A equals half of C and B equals half of C, that is A and B both are equal to half of C, then A will be equal to B. This was Euclid's seventh axiom. Students, now let's study about Euclid's postulates. As you can see on your screen, the first postulate is a straight line can be drawn from any one point to any other point. As you can see, we have 2 points A and B, and joining these 2 points we can form a straight line. Similarly, you can take any 2 points C and D and make a straight line by joining these 2 points. So this was Euclid's first postulate. Now let's study about his second postulate. A terminated line can be produced indefinitely. Now students, by terminated line we mean a line segment, but according to Euclid, a terminated line, it can be increased or produced infinitely in both the directions. So if you have a terminated line, you can produce it infinitely. This was his second postulate. Third postulate was that a circle can be drawn with any center and any radius. That means if we have put a dot on a plane surface, we can take it as the center of the circle, and with any radius we can form a circle around it. You can take any center at any plane surface, and with a given radius you can draw a circle around it. Now this means we can take a center O on any plane surface, and we can take radii like 2 cm, 3 cm or 4 cm, and we can form a circle with these radii. Next postulate is all right angles are equal to each other. Now students, as we know, a right angle equals to 90 degrees. So wherever you form a right angle, all those right angles will be equal. You can see a right angle on the edges of your books or your tables, on the walls or this white board, and all these right angles, as they will be equal to 90 degrees, so all right angles will be equal. Now let's see Euclid's fifth postulate, which says If a straight line falling on two straight lines makes the interior angles on the same side of it taken together less than two right angles, then the two straight lines, if produced indefinitely, meet on that side on which the sum of angles is less than two right angles. Now see, as you can see in the given figure, the line PQ falls on lines AB and CD such that the sum of the interior angles 1 and 2 is less than 180 degrees, as you see on the left side of PQ. As you can see angle 1 and 2 blinking here. Their sum is less than 180 degrees on the left side of PQ. So, if we produce lines AB and CD indefinitely in both directions, we will see both these lines will meet on the left side of PQ. So, it means the side where the sum of interior angles will be less than 180 degrees, both lines AB and CD will be meeting on the same side, that is left side of PQ. This explains Euclid's fifth postulate. So students, so far we have studied about Euclid's axioms, postulates. Now I am gonna ask you some questions. I hope and I am sure you might be knowing the answers of all these questions. First is, as you can see on your screen, a line has dash points. A line has dash points. I am giving you some options. First option is limited. Second option is infinite. Third option is none. And fourth option is 10. Now you have to tell a line has dash points. Now students, as we know, a line can be formed by joining infinite points. So how many points does a line have? Infinite. So the correct answer is infinite. Now let's see another question. If the area of a triangle formed by joining 3 points is 0, then the 3 points are dash. I am giving you options. First, collinear. Second, non-collinear. And third, none. Now students, think, if the area of a triangle is 0, it means that the 3 points are on the same line, as they were not able to form a triangle. And if the 3 points are on a straight line, that means the 3 points are collinear. So the correct answer is collinear. Now let's do the third one. Next is, things which are equal to the same thing are dash to each other. The options are equal, second, similar, third, not equal. Now students, Euclid's axiom told us that things which are equal to the same thing are equal to each other. So the correct answer is equal. I hope you might have got it well in hand. Now let's move further. Next is, what is the width of a point? I am giving you options. First is 1 centimeter, second is 2 centimeter, third is 3 centimeter, and fourth is none. So students, you have to think, what is the width of a point? I am giving you time to think. I hope you all know its answer. The answer is, a point has no width, no length, no area. So the correct answer is none. Now students, let's match. Students, as you can see on the screen, we have 3 pictures on the left, and on the right we have one-dimensional, second is 3-dimensional, and the third is 2-dimensional, and we have to match these. Now as we can see, the topmost figure on the left, it is a 3-dimensional figure as it has length, breadth as well as height. So this is 3-dimensional. We will join it with 3-dimensional. Second figure, you can see it has only length and breadth. So what does it mean? It means it is 2-dimensional. So we join this figure with 2-dimensional. And the third one is a straight line. And as we know, a line has no width. So this is 1-dimensional. We join this line with 1-dimensional. So students, today in this chapter, Euclid's Introduction to Geometry, we have studied about Euclid, his book Elements, and his axioms and postulates. I am sure you all have learnt all these concepts very carefully. Thank you.